My name is Andreas Höschler, Managing Director of Advanced Science Subdivision at SmartSoft. Let's make use of Cassiopeia again to solve a couple of problems. We start the application and log into the local database as usual. In this tutorial we will look into solving quadratic equations, solving a volume integral, a differential equation, and we will plot a couple of functions. Let's get started. Find the roots of the following quadratic equation and plot the function. Okay, let's make a duplicate of this equation by double-clicking on it, and let's set this to 0. Double-click again to duplicate and divide by 3. We will use the PQ formula to solve this equation. It is minus q. For x1 and for x2 we have minus the root. And in this case we have p 2 over 3 and q is minus 3. Let's make a copy of this one and drag in these guys. Now we can make use of a new feature of Cassiopeia, which is a Command-Alt double-click to solve such an equation and calculate the actual number. We do the same for the second solution. Drag in the guys and do a Command-Alt double-click. Oh, you should go here. Let's make a duplicate of this equation and then plot it with the shift double-click. Reasonable limits. Let's take minus 5 to 5. Okay, here we go. x2 is, this looks reasonable, x1 looks reasonable as well. Great. Next exercise. Calculate the volume of the sphere. Do so by finding the infinitesimal volume element in spherical coordinates and integrate over r, alpha, and beta. Okay, let's see. We have r squared sine beta t alpha dr for the infinitesimal volume element. We can now press Command-Shift-P to open the palette and look up the integral we need. That will be this one. Okay, let's create a new equation and say the volume is this integral dv. Now we drag in this guy. Alt pressed to get a new equation. Let's make a Alt double click on this to expand and then go to the first integral and upgrade that. Integration limit for beta is pi. Next one, Control Y to upgrade. Integration limit for alpha is rho to 2 pi. And the next one will be integrated from 0 to uppercase r. Okay, I'll double click until Cassiopeia has calculated the solution for us. Here we are, problem solved. Next one. A capacitor is charged and then attached to a coil. Ideal case, no resistance. Find equations for U and I. Okay, let's see. For the coil we have di over dt, and for the voltage over the cap we have Q over C. Let's put that into an equation. Oh, sorry. And drag these guys in. Let's divide by L. And realize that di over dt is actually the second derivative of Q. Okay, let's make the following approach. We need the second derivative. Cassiopeia will do the work for us. No need for the first one. Let's get rid of it. Okay. I times I gets us minus, and this is squared. Let's make a double click of this, duplicate of this equation. This is actually, if we write it this way, we can automatically substitute. I drag. Okay, let's get rid of that one. We can factor out this term here. And get rid of that one as well. Okay, it can easily be seen that this equation is true for all t only if this expression is 0. So we have one over CL. And that is actually the solution. We can simplify this Euler thing in the general case to something like that. Oh, sorry. For Q, I will be the first derivative of this equation. So let's Cassiopeia do it again. Differentiate and call this I. And U will be the voltage, this beast over C, or simply UO. That's it. Let's invert a function graph and drag these two functions onto it. Use reasonable limits and introduce some color. Red for the current and blue for the voltage. Let's close this guy. Here we are. Homework done. Let's write this into a file and send it to our teacher. Here it is. Attach this to an email and your teacher will be happy. Or simply generate a PDF. Okay, thanks for watching.